Hello?
Hello? Bueno.
All right, 5.5, the indefinite integral method of substitution. So, substitution method is key, mandatory. This is one of those things that is so super helpful because you can't always take an integration of something. You can't. And so you have to try and find a way to do it. It's kind of like doing the chain rule. Okay? When we have a derivative, right? Derivative, chain rule, inside, right? Mm-hmm. That's kind of what we're doing for this. So if I see something that I would want to do the chain rule out of, then there's most likely going to be some type of substitution that I need to use. Okay? So you guys know the derivatives. Okay, do the chain rule, right? But integration doesn't have a chain rule. But you're usually got to look at the format of what you have to see, oh, okay, I'm going to have to sub this. Okay, so indefinite integral, right here, it's the integral plus c. So indefinite, just whatever it is, plus c, right? Okay, what about a definite would be?
Without c.
Without c, why?
Because we know everything.
Because you have bounds, right? Okay. So, there we go. Here's a whole bunch of rules for you.
It's hard to see.
I know it's hard to see, but does this look familiar?
Oh, it's on the flashcard.
It's all on the flashcards. That's the reason why I am trying to make a big point about this. You really need to have these down. Okay, you really do, because it's going to keep coming up over and over and over and over again, over and over again, and over again.
And over again?
And over again.
And over again.
And wait.
Over again?
Over again.
Wow. And over again. Caught me off guard.
All right, so find indefinite integral. So now right here, what's this one right here going to be?
X to the 5 over 5.
There we go. So we're going to have x to the 5 over 5 plus c. Yes?
Yeah.
Okay, so let's rewrite b. How would I rewrite b?
X to the 5
X to the
1
1/2,
half.
right? Okay, so integrate that. So it's going to be,
2/3 of x to the...
so watch this, watch. I'm going to show you guys. This is always the way to do this, because you do your exponent first. So you do x to the, I add 2 over 2, right? Because I'm adding 1, right? Add 2 over 2, which gives me 3 over 2. But I'm dividing by 3 over 2, so I multiply by the reciprocal, which would be 2 over 3. And then I add plus c. Okay, all right. So can I rewrite the sine over cosine squared?
Yeah,
What's sine over cosine? Tangent. And don't I have one more? So it's going to look like this. So it's going to be sine cosine times 1 over cosine, right? Okay, so I could rewrite that as the integral of tangent of x times secant x. Ooh.
Oh, wow.
Tangent secant or secant tangent. Is that on here? Yes. Or if you guys remember the derivative of secant, right? The derivative of secant gives me secant tangent, right? So the antiderivative of secant tangent should give me secant. Secant x plus c. Properties, indefinite integrals, a derivative of an indefinite integral. Okay, so if I'm taking the integration of the derivative should just give me the function, right?
Yeah.
Okay. So same thing goes here. So property 1, so if is a consequence of the definition of integration of fx for the example here. Okay, we could actually have this right here. If it's the derivative of the integral, okay, so it's going to get that. So from here, it breaks down into this inside function derivative of, yes, so square root of x squared plus 1. Square root of x squared plus 1. Is it on here? Okay. All right. Yeah, this is just the properties for it. Indefinite integral sum of two functions. So I could separate it into two separate functions.
So that's the same thing that we did before, but we
Yeah.
added C to it?
Yeah, so now this is with C. So there's no bounds.
Wait, but why there no plus C?
Yeah, it's a good question.
Okay, did I take the integral of it?
You didn't take
If I take the integral of it, it's going to be whatever capital F, this would be capital F plus capital G plus C. Okay, because I would have a plus C from the F, right? And I'd have a plus C from the G, wouldn't I?
Yeah.
So I would have two separate constants, don't I?
Yeah.
But the constant plus the constant is another constant, right? So I'm just combining them both into just one constant. So it's just going to be some one constant out of it. Just like when we did earlier, it's 2 times a constant, it's still a constant. Make sense or no? Okay, so. Alright, so right here, if there is a factor, I could factor out of it. Constant multiple rule, so I could actually take that bad boy out. Put it in front of my integral. Okay, for this right here, I'm going to break it up into two separates. So this is going to be integral of 2. Ooh, crap. Watch this. Watch. Integral of 2 x to the 1/3 dx plus 5 integral of x to the -1. Ooh, I don't want that x to the -1.
We're gonna do
Actually,
that.
no, I'm gonna leave it like that just because. See if you guys can see that one. Okay,
Isn't it just an
it's going to, but I wanted you guys to be able to see that. All right, so now from right here, this is gonna give me 2 times whatever my integration is. So it's gonna be
2 times.
okay. So now let's do my x first. X to the 4/3 because I'm adding 3/3, right? So it's 4/3. 3/4, so it's over 4 here, right? Okay, so there's times of 2 also, isn't it?
Yeah, so it's 3/2.
Okay, so it's going to be 3/2. Did I do too much math in my head?
No.
Yes? Yeah, here, I'll fix it.
Yeah.
So, x, you guys okay with 4/3, right?
Mhm.
Okay, so it's times 3/4, right?
Mhm.
But there's also times this 2 out here, isn't it?
Wait, how'd you get it?
Okay, so every time you look over, I'm telling you, focus. Okay, what do you do to your exponent?
You added to
Add how much?
3.
You add, no, you always add what? 1, right? You're adding 1, right? You're adding 1. But in this case, since it's a fraction, my 1's going to look like what? 3/3, right?
Okay, I get it.
So that's where I get the 4/3. And then since I'm going to divide by that same number, I'm multiplying by the reciprocal. Right?
Yeah.
Okay, then I'm going to put my plus C over here. Alright, so now this one right here. So if you guys can see that one, it's actually going to be, if I were to add 1, what happens? if I add 1 to that, what happens?
It's gonna be constant.
Look at
Oh,
my
wait,
variable.
Oh, that one, it's gonna be 0.
Oh, got it, okay.
It's going to be x to the 0, right?
Yeah.
Okay, so that's a special rule. That's a special rule. So if I'm taking the integration and it gives me a 0, it gives me a 0 that comes up with an ln x. That's a rule, and it's actually on the car right
There somewhere.
here. It is. It's right there on that one. So 1 over x is basically ln x. Okay? All right, so it's going to be plus 5 ln of x absolute value. Because if you forget that, you're going to be in trouble later on. You're going to be in trouble later on. All right, and plus c from that one. Okay, so now I have 2 constants. I don't know what they are, but when I add them up, I just get another constant, right? So yeah, so I'm just going to call it 1 constant. So now I'm going to reduce this right here, so it's going to be 3 over 2 x, oh my goodness, x to the 4/3 plus 5 ln of x plus c. Make sense? Okay, good. All right, let's do this one then. So let's rewrite first. Yep. 12 integral.
Is that 5?
Yeah.
Yeah.
-5, right? Whenever I'm doing this, I want to have it in the numerator. I always want to have it in the numerator. I'm okay with negative exponents. Okay, have it in the numerator. That's going to help me out.
Plus.
Dx,
Oh, yeah.
because you're closing that one, right?
Yeah.
You're closing that one, so you have to dx that. Because sometimes you're going to have a different integral. A different integral. So on the AP exam, if you don't close it with the dx right here, you're wrong. Okay, it's a wrong statement. Plus, what's this next one?
Integral
Integral
of x to the 1/2.
Actually, -1 over.
-1 over 2, right?
Yeah.
There we go. All right, so add 1, -4, right? So it's -4, so it's x to the -4 over,
-4.
which gives me
Negative x to the -4 over 4.
right?
Yeah.
And that's going to be times,
12.
yep. Okay, then plus my c, and this is going to give me, let's see, plus, right?
Yeah.
Because I'm going to add 1, so that's going to add 2 over 2, which is going to be 1 over 2, right? So it's going to be x to the 1/2. And if I'm dividing by 1/2, I'm multiplying by reciprocal. So I just get 2, right? And plus another c, right? Okay, so let's go ahead and clean this bad boy up. Okay, what can I do that x to the -4?
On the bottom.
Bring it back down, and then 12 and the 4,
It's gonna be -3 over
x to the 4th, plus
2 square roots of x.
2x to the 1/2. I like exponents, I really do. I hate writing the radicals out. And then plus some constant, right? Okay, are you guys done writing? Because I'm going to have to clear up my board for this one. Alright, so let's clean this one up. Now this next one. Okay, using properties of indefinite integrals. Now, I'm going to have to do something special in this one. Okay, because there's a binomial in the bottom, I'm going to try and do a long division here. Okay, I'm going to try and do a long division because I cannot have it like this. Okay, so I'm going to try a long division here. Okay, let's see. I have x squared plus 6. And I have, ooh, wait, hold on.
It's without square root.
No, it's not that. It's x squared plus 0x plus 6. And then I'm going to have x squared plus 0x plus 1. 1, right? Yeah, long division. Alright, so that's going to give me 1, so it's going to be x squared, right? And plus 0x plus 1.
Which leaves 5.
Okay, from right here, it's just going to give me what?
5.
Okay, 5, so that's going to be plus 5 over x squared plus 1.
Oh.
Excuse me.
That makes sense.
Okay. And now we can.
Now you could do it. So now it's going to be the integral of 1 dx plus the integral of 5 over x squared plus 1 dx.
And then we rewrite the right one to. This one is going to be just 1.
Nope.
Or 0.
Nope.
X.
X.
Oh yeah, it's X.
It's an x, isn't it? Right? It's an x. So I'm going to have x here plus c, right? So it's x plus c.
Plus 5 times
5
times arc tangent X.
arctangent of x plus c, right? And so together I'm just going to come up with x plus 5 arctangent of x plus c, constant. So that wasn't so bad, was it? Okay, we couldn't do this one right away because I have the mess in the top, right? I couldn't do that, so I have to do some long division to try and break that up. All right, substitution. Okay, this is actually very informational. It really is. And I'm gonna give you guys the basic, like the plain English way to say all this. Okay, so if I was to take the derivative of that, you would do what? Okay, so if I'm gonna take the derivative, let's say this is d dx, what would I do?
Like first the inside derivative.
Yeah, inside.
Okay, so that what rule is that?
Chain.
Chain, thank you, chain. Now what is the piece that makes it the chain?
Inside.
The inside, thank you. So that means that I'm gonna make u, this is my u substitution, is equal to the inside.
You can do that like this?
Yes, that's what it's called, okay?
No, I know, but it just.
That's,
I said you can do it in this.
yes, but this is not chain rule. This is called the u substitution,
Yeah.
okay? You know, I'm gonna have some u sub t, I even have a problem that I go all the way down to like t or something like that.
Okay.
Anyway, so for this, you have to do this right here, okay? What's the derivative of u? du, right?
Yeah.
Because the derivative of x is just 1.
Got you. Yeah.
So the derivative of u is du. Okay, so the derivative of u, right? Yeah? Okay, good. All right, so every time we do that, so now what is the derivative of 3x plus 2?
Just 3.
3. Now, I took a derivative in terms of what?
Of x.
Of x. So, since this is going to be of x, it's now going to be called dx. And just for the sake, since we haven't done this before, I'm going to show you where and why. If I divide by dx, so I'm going to say that the derivative of u in terms of x is 3. That's where we get the du dx, or the dy dx. Okay, so now I'm calling it u here, so it's just going to be that, right? Yes? That's where this comes from, the du dx is going to be. So when I took this function right here, I replaced it, now it's going to be that. So that's where that came from. All the time where I kept telling you, you got to label your stuff, that's why we're labeling it. Okay. So now I'm going to substitute u. So I'm going to take this out, so it's now going to be the sine of u, okay, the sine of u. But now I also have to replace the dx. So using this next line right here, what would I do to replace the dx, to get dx by itself?
dy over 3.
Divide by 3. I'm going to divide by 3. Let's do that. Divide by 3. So it's 1/3 du. Okay? So I'm going to replace the dx with 1/3 du. So it's times 1/3 du. So now this is going to be correct because I am no longer taking the integration in terms of x. I'm taking the integration in terms of u. So I change this now to u's. So everything is all changed now. So let's go ahead and take the integration of this. So what do I do with that 1/3? So you put it up front. That's a constant, isn't it? Okay, so that's some coefficient that I'm gonna factor out of the front. So now what's the integration of sine u?
Negative cosine?
Negative cosine. Very good. So it's gonna be negative, how much?
1.
1/3 cosine of u plus c, right? Yes? Okay, so now, because this, I have now done the integration. So now what do I do now? Put,
Instead of u.
yeah, put back what we replaced with u, right? So I'm going to do that. So it's going to be negative 1/3 cosine of, that's going to give me 3x plus 2 plus c. Is that neat? A lot of these are just going to be some neat little trick that's going to help us out. Can I erase now? Okay. All right, so this next one. Where's that chain rule lie at? Inside, right? Now, because these are puzzles, they're puzzles. You have to make it work. You have to sometimes change what you're trying to do. This is going to be a puzzle. So I'm going to say that u is x squared plus 1. Du is going to be what? 2x
Yeah.
dx. Very good. 2x dx. Okay. So now, when I do this, what is it I actually have to get rid of here? I have to look over here. When I'm substituting for my dx, I'm replacing it with, I have an x there and an x there, right? And I have a dx. So I have an x and dx that has to be replaced. So now, what do I do with that 2? Oh, yeah, divide by 2. You'll see why. Because, watch this. So u is going to be all of that. So this is going to be u to the 1/2, right? Yeah, the radical, right? Now, I'm going to replace what? X dx with, look, x dx right there. Those are the two things I'm replacing, right?
I did it.
X dx with 1/2 du. So it's going to be times 1/2 du. It's kind of nifty how this works out, right? That sometimes it's just going to be really neat and just take care of everything.
I thought we're just gonna find x from the first one, from u equals x squared plus 1, and like take that.
It works. It works every time.
I know, but
There's a proof for it if you want to look in the book. So I don't want to go through the proof.
no, I'm not.
Yeah. So now let's go ahead, take the integration. So the integration is going to be
2 6.
So I'm adding 1, right?
Yeah, so it's gonna be 2 over 6 times u to the 3 over 2.
Oh, I'm not going that far yet. I'm taking out the 1/2, right?
Okay.
1/2 parentheses u to the
3 over 2.
3 over 2 times
2 over 3.
2 over 3, right? Okay, and that's going to be plus my c, right? Okay, so what's going to happen to my 2's right here?
Cancel.
Yeah, these 2's right here will cancel because I have a 1/2 and a 2 on top right there, right? Okay, so when I do this, I'm just going to plug my u back in. So I now am going to say that this is going to be x squared plus 1 to the 3/2 power over 3 plus c. Happy day? Can I erase? Last one. What's the tricky part?
Square root of x. And then change it to u.
Okay.
And then
So you just said the square root of x, right? So I don't always have to just take the inside. Let's just take that whole nasty bit, right? So let's say that u is equal to, you said square root of x? So that's x to the 1/2. Okay. Let's see. So I'm going to get du is equal to,
x to the 1/2 of x to the negative 1/2.
yeah, so it's going to be 1/2 times,
X to the negative 1/2. dx.
right? Okay. But I'm going to clean up my math on the right-hand side of that just so it makes it more obvious of what I'm doing with it. So I'm saying that I'm going to have du is equal to 1. Come on, my pen's running out of ink again.
Besides this, it's fine. Because the joke is all.
What is funny?
So, no,
Now, can you guys see it now? Can you guys see it? What it's going to do now? Let me rewrite this. Let me rewrite this.
oh, maybe.
If I rewrite this, it's going to be the same as saying e to the, right? E to the x to the 1/2, right? Over x to the 1/2, right?
And we can rewrite it as, okay. So we can just change dx and 1 over x.
Yeah. So now in this case right here, let's look. In this case right here, I'm going to replace what?
1 over x half dx.
Yes. I'm going to be 1 over So I need to take care of that, and I will be able to here, right?
Yeah, we just need to
So,
multiply by 2.
Multiply both sides by 2. So now my dx is going to replace, so it's going to become 2 du is equal to 1 over x to the 1/2 dx. So hey, I'm going to clear up all that mess down there.
And
Now it's going to be the integration.
2
So I'm going to have 2, right? I'm going to take out that 2.
e to the u.
So e to the u du.
That's pretty easy.
Did I mess you up?
A little.
Okay, so do you want me to rewrite it or no?
Yes.
Oh
It's
my,
just-
you messed up.
I get,
Yes.
So this, because this and this are going to be substituted with this and this. So I'm going to replace my dx and x to the 1/2 with 2 du.
Oh, okay, makes sense.
okay,
Is that better?
yeah.
Okay, so now from there, so now it's going to look like this. So I'm going to go, so integration of e to the u times 2 du, right? Okay, what am I going to do with that 2? It's going to go out front, right? Or, it doesn't matter. What's the integration of e to the u?
E to the U.
E to the u. So it's going to be 2, because it's 2 times e to the u plus c, right?
Or e to the square root of x.
So that's going to end up becoming 2 e to the x to the 1/2, right? And then plus c. All right. You guys happy about this?
Yeah.
Okay, you're feeling pretty good, right?
Yeah.
All right, so
Sorry, I missed that.
don't forget, like, share, and subscribe.